Okay, so our last example. F of x equals x squared minus 1. Determine the equation for the inverse, then graph both. Well, let's start off with determining the equation. The original function is f of x equals x squared minus 1. Notation change, variable change, isolating for y, square rooting both sides, and there you go. Let's graph both of them. Graphing f of x, I'll graph it in blue. Graphing f of x, this is x squared minus 1. So using the exact same argument that I had before, it's going to be the base function is y equals x squared. So that's 0, 0, 1, 1, 4, 2, 4. I'm going to move it down 1. So it's going to be 0, negative 1, and 1, 0, and 2, 3. It would then be 3, 9, no, but that'll be off the curve. So here we go. Notice how quickly I was able to graph that. You want to be quick at doing this stuff. So that's f of x. We'll throw in the line y equals x. So 1, 1, 2, 2. So it comes out through here. So that's going to be the line y equals x. And we need to reflect this. So this part's going to come down over here. This part's going to come up over here. And this part's going to come down over there. That's what I know is going to happen. I can do a little bit of transformation. I know that it's x comma y goes to y comma x. So this point here might be easy to do is negative 1. No, it's 0, negative 1. So it's going to become negative 1, 0. So negative 1, 0 is here. So this point moved to here. That's not an invariant point. That point actually moved. It's just lying at a point that there used to be a point there as well. This point that was there, negative 1, 0, is actually moved to 0, negative 1. So that point moves to there. So this point went there, this point went there. They changed spots. What's going to happen now is maybe this point I can move, which is 1 comma 0. So that's 0 comma 1. So that's going to be here. So let's see. That got moved, that got moved. So I'm seeing something like this. Now let's move this one. This one was 2 comma 3, so it'll become 3 comma 2. This point out here was negative 2 comma 3, so it'll be 3 negative 2. And we have an idea of what this looks like. And if we think about it, that should be made up of the two arms here. There should be one arm, which is x plus 1, the square root of x plus 1. So there's my normal square root x. Plus 1 is movement to the left horizontally, 1 unit. So 0, 0 would become negative 1, 0. And then 1, 1 would become 0, 1. And then you would have out there farther should be 4, 2. So move it back 1 would be 3, 2. It works. And this bottom part here will be, I'll use a different color just so that we can see it, negative root x plus 1. And that would be that arm coming down here. It's because what we're talking about is that if this is f of x, this is simply negative f of x. That's a reflection of this top one in the x-axis. So there we've got the inverse. Now, let's just call it the inverse because it's not a function. And I've just given away this. Is the inverse a function? In this case, no, it's not. It does not pass. Does not satisfy the vertical line test. What that means is that there's a value of, so here's a vertical line. I'll go through here. That vertical line has two y values. So there are values of x with more than one range value. Therefore, it's not a function. Is it a relation? Definitely. It's still a relation. Anything with ordered pairs is a relation. Oh, you can't see. There you go. State the domain and range of this inverse. It's not a function. We're just going to call it an inverse. So the domain and range of this inverse is going to be negative x. So the domain of the inverse is going to be x such that x needs to be greater than or equal to negative 1, and x is an element of the real numbers. And its range is going to be such that y must be, okay, looks like y can be anything. Would you agree? Y is an element of the real numbers. Now that's interesting, because if that's the case, then it hasn't asked for this, but let's think about this. If that's the case, then the domain and range of f of x would be interesting. It should be the opposite of this. Okay, so the domain becomes the range becomes the domain. So I'm thinking that the domain of this puppy should be x is an element of the real. And I'm thinking that the range of the original should be y is greater than or equal to negative 1. Let's see if I'm right. Looking at the blue one, x is an element of the real numbers. Yeah. And looking at the range, y is greater than or equal to negative 1. Hey, it works. Pretty cool. Let's see what the last question says. Restrict the domain of f of x so that the inverse actually is a function. So we want to make it so that the inverse is actually a function. Well, there are a gazillion different ways to do it. But what you have to make sure is that for every value of x on this function, for every value of x on this function, there is absolutely only one value of y. And one way to do that would be to isolate it so that there was only one of these arms. Now notice what it says. Restrict the domain of f of x. So we want to restrict the domain of f of x so that when we do take its inverse, we get a function. So the domain of f of x, what would happen if I only used this arm? If I only used this arm, then the reflection would only be here. We wouldn't have this bottom part because that comes from this arm. So if I only used this arm, then I would only get the top part. And so if f of x was restricted to the set of all x such that x had to be greater than or equal to 0, and x could be any number in between, then f inverse would only be that one. Now, it's also true, what if I only use this arm? Then we would only get, flip it over. If I only use this arm, we flip that over, I'm only going to get that portion. Okay, so this arm would, oh, you can't see, I'm sorry. This arm reflected over will give me that arm. So we could also, or if f of x was restricted to x such that x was less than or equal to 0, then f inverse is also a function. Okay, well there you go guys. That takes me up to 181. I'm wondering if there's any others that I need to do here. it doesn't look like. I'm looking for homework. I think I'll have to post that on the LMS because it's not listed at the end of this page. And so there you go. I'll be posting some practice tests. I'll be posting some other things. Take a look at those. Make sure you're ready. And we will see you Monday. Bye-bye.